All right, let's dive into one of the most critical and frankly one of the most in-demand careers in tech right now, data engineering. If you've ever wondered who's behind the scenes building the massive digital infrastructure that powers pretty much everything we do, well, you're in exactly the right place.
It all starts with this number. It's a number so big, it's kind of hard to even wrap your head around. In 2023 alone, we, the world, created 132 zettabytes of data. And that number, it's just growing faster and faster every single year.
To try and put that into perspective, that's 132 trillion gigabytes. This isn't just a bunch of files, it's the new oil, the new gold. We are absolutely living in a data gold rush, and every company out there is racing to find the value buried inside this mountain of digital ore.
But think about it. Raw gold just sitting in the ground isn't very useful, is it? You need someone to build the mines, the railroads to transport it, and the refineries to process it. So, who is building those digital railroads and pipelines for all this data? The answer? The data engineer. So yeah, this massive explosion of data, this gold rush, is the fundamental problem that data engineers get hired to solve. You can think of them as the architects of this whole new industrial revolution. Honestly, they make everything else in the data world possible.
So what is a data engineer exactly? Well, simply put, they're the architects and the builders. They're the ones designing and creating these huge, complex systems that collect, store, and process unbelievable amounts of data, making sure it's all clean, reliable, and ready to go for everyone else.
But here's the thing, the data engineer doesn't work on an island. The data world is full of different roles, so let's get really clear on how an engineer is different from, say, a data scientist or a data analyst.
This really breaks it down nicely. The engineer builds the reliable infrastructure, the foundation. The scientist uses that foundation to build predictive models and find hidden insights. And the analyst? They take all that data and interpret it, creating reports and dashboards that explain what's going on. Here's a good analogy. The engineer builds the highway. The scientist designs the self-driving car that runs on it, and the analyst studies the traffic patterns.
But here's the twist. In 2025, those clean lines we just drew are starting to get, well, a little blurry. The roles are evolving, and companies are now looking for people who can do more.
And wow, this chart just says it all, doesn't it? When we looked at job postings, we found an almost perfect 50-50 split. Half the companies out there want a deep specialist, a true domain expert. But the other half? They're looking for versatile professionals, sort of a Swiss Army knife who can wear multiple hats. And why is this happening? It's because of things like ML Ops, where engineers need to understand the entire machine learning process, not just one piece of the pipeline. It's a huge trend toward end-to-end ownership.
So, with that trend in mind, what skills do you actually need in your toolkit to land one of these jobs in 2025? Let's take a look.
At the heart of it all, it starts with programming. Look, Python and SQL are the absolute 100% non-negotiables. After that, you've got languages like Java and Scala, which are super important for building really high-performance systems that can handle just insane scale.
And the data could not be clearer on this. Python shows up in 70% of job postings, and SQL, it's right there at 69%. It's basically a tie. If you're starting out, mastering these two is step number 1, 2, and 3. But languages are just the beginning. You've also got to know the key platforms. That means being comfortable in a major cloud environment like AWS, Azure, or GCP. You'll need big data frameworks like Apache Spark to process huge data sets like Lightning. You'll need to understand different kinds of databases and, this is a big one, orchestration tools, which are like the conductor of an orchestra, making sure all your complex data jobs run in the right order at the right time.
So let's zoom in on that orchestration piece for a second. This table is a great cheat sheet for two of the leaders, Airflow and Prefect. Airflow is the big enterprise standard. It's all about stability. Its philosophy is configuration as code, and it uses something called DAGs. That's just a fancy way of saying a workflow where tasks have a specific order. On the other hand, you have Prefect. It's newer, more flexible, and it's built around this really interesting idea called negative engineering. Basically, it just assumes things will fail, and it makes it super easy to handle those failures. Which one you choose really depends on what your team needs.
Okay, so you know what's in the toolkit. Now, how do you actually put it all together to build a career? Let's walk through a clear blueprint to get you there.
It's a pretty logical path if you think about it. First, you master the fundamentals, Python, SQL, how databases work. Then, you get your hands dirty with a cloud platform like AWS and a framework like Spark.
From there, it's all about practice, practice, practice. Actually designing and building those data pipelines that move and transform data. Then you embrace data ops, which is just like DevOps but for data. It's about using tools like Git and Docker to make your work automated and reliable. And finally, and this is the most important one, you build a portfolio.
And I have to pause here because this is probably the most important point in this whole explainer. The crucial point is this: theory is not enough. You can take all the online courses in the world, you can read every book, but to actually get hired, you must build things.
And hey, don't just take my word for it. This quote from an experienced pro on Reddit just nails it. A real working project that a hiring manager can see on your GitHub is worth so much more than a certificate from a course. It proves you can actually do the work.
And if you're thinking, okay, but what do I build? Don't worry, there are tons of fascinating public data sets out there. You could analyze carbon emissions data, try to optimize revenue for a fake online store, or do something fun like figure out the golden age of video games. Just pick something that sounds interesting to you and start building. So, if you follow that blueprint, you put in the work, and you build out your skills, what's the payoff? Let's talk about the job market, because it's pretty impressive.
The demand for data engineers is just staggering. In the past year alone, more than 20,000 new data engineering jobs were created. Companies are desperate for people who can build and manage their data infrastructure.
And as you'd expect, that high demand translates directly into high salaries. The average salary for a data engineer in the US is sitting around $130,000 a year. It's a seriously lucrative field.
And that salary grows fast. You're starting out strong, right around $106,000. But with just a few years of experience, that jumps to over $133,000. And senior engineers with 10+ years in the game, they're commanding well over $150,000 and often much, much more.
So, there you have it. Data engineers are the essential architects of the digital age. They turn the chaos of raw data into the foundation for everything from business insights to AI. They're in high demand, they're well paid, and their work has never been more important. So the real question isn't just, are you ready to build the future? It's what part of it are you going to build first?